Welcome everyone. In this video lecture, we will think about a numerical problem which is from the Microelectronics circuit book, and it is problem on operational amplifier, basically inverting amplifier. So the question is, consider the inverting configuration with R1, the systems having R1 1 kilo ohm and R2 100 kilo ohm. So we have to find the closed loop gain for the cases A 10 to the power 3, 10 to the power 4 and 10 to the power 5 means for a finite gain, finite open loop gain, not for the infinite open loop gain. In each case, we have to determine the percentage error in the magnitude of G relative to the ideal value of R2 by R1. Okay, so basically what they are asking, this one is a inverting amplifier. So for the A value infinite gain, the value gain will be minus R2 by R1. Okay, but if we take the some finite value, so the gain will be somehow changed. I have already made a video on this topic to how to find this gain V naught for a finite value and Vi. So that will come minus R2 by R1 whole divided by 1 plus in bracket 1 plus R2 by R1 bracket divided by whole A. So the proof is already done in my earlier video. I will share the link in this video. So we have to go for this formula. Okay, so it is very simple. Calculation is also there. Means for the A value, this point means this value will be simply our minus V naught by A. Means voltage across this point will be minus V naught by A. Then if we apply the I1 current will be flow, and if we solve this one, it will give this value. Okay, so I'm not going to prove this one. We will use this formula directly, and I will share the link for this theory. Okay, so we have to find the percentage error in the magnitude of G related to the ideal value of R2 by R1, and also determine this V1, this value V1. Okay, for given input voltage 0.1 volt, that we have to find out. Okay, and the other thing, if the open loop gain A changes from 10 to the power 5 to 15 to 10 to the power 3 means just half percentage of by 50%, what is the corresponding change in the magnitude of the closed loop gain? That so the very first thing in this question is to find out the percentage errors. Okay, so I am writing a part, percentage errors, or we can say the percentage eta, anything symbol we can say. So what we have to do, the gain magnitude relative make G means overall gain with the finite open loop gain G minus what we can write R2 by R1. There is the middle one, or better to write in magnitude. Okay, G minus R2 by R1 by this one, R2 by R1 into 100%. That we have to do. Okay, means percentage error, the gain related to the ideal value means R2 by R1. Okay, this G for the finite output open loop gain by R2 by R1 into 100 we have to find. Okay, in the part 1. Okay, so and the value of V1, this value V1 will be simply our minus V naught by A. Okay, this value for the finite output resistance, finite open loop gain means this A is nothing but simply V naught by V plus minus V minus. Now this V plus is 0 volt grounded. Okay, so V minus is simply our, if we solve it will come V naught by A. I have already proved all these things. Okay, in the my last video, basics of this is how to do the gain, all these things. So this one is the three formula that we have to take care for the first part. Okay, so now we have to make a table, means what are the findings we have to uh, calculate, like means we have to do it for different gain value, different loop gain, like this. Okay, A 10 to the power 3, 10 to the power 4, 10 to the power 5. Okay, so what we are doing here, I am making a table. Means A value we have to write, and we have to find the gain, percentage error. Oh, sorry, write it percentage eta. Okay, percentage eta, and one more thing, v1 is needed. Okay, this thing we have to find for different value, like in our question for 10 to the power 3, 10 to the power 4, and 10 to the power 5. We have to do it for these 5, these 3, sorry, these 3. This A is nothing but simply open loop gain. Open loop gain. Okay, when open loop gain A is infinity, this one means V naught by V in. For A infinity, simply minus R2 by R1. But here we have to do it for some finite gain. This A is some finite value. When this one is some finite value, we have to go for this formula. Okay, so now we have to find the gain. Okay, so gain formula we have written here. Okay, so first we are doing for the what we can write for A equals to 10 to the power 3. For A equals to 10 to the power 3, what we have to do, we have to find the overall gain for the finite open loop gain 10 to the power 3. So formula is already written here. Okay, one more times I am going to write R2 by R1 divided by 1 plus 1 R2 by R1 by A. When A is infinite, simply if we say A is infinite, it is 0, so it should be minus R2 by R1. But this one is the formula. So now what we have to write, minus R2 on R2 value is given, R1 value is given in the question. Okay, I will once again show you. R2 is 100 and R1 is 1. R1 is 1 kilo ohm, R2 is 100 kilo ohm. These are the given parameter. So R2 by R1 will be simply minus 100. Okay, kilo will be cancelled, minus 100. Then 1 plus R2 by R1, 100, then 101. Okay, then 101 by A is 10 to the power 3. Okay, so I am directly writing minus 100, then it should be 1 plus 0.101, means minus 100 divided by 1.101. Okay, so if we solve this one, it will come nearly minus 19.826, which is equivalent to minus 90.83. So this value will be what we are writing in magnitude. So write it 90.83. Okay, now this one is clear. Now we have to go for the error. So percentage eta. So for the formula, we once again I am writing G minus R2 by R1 by R2 by R1 into 100 for percentage error calculation. We are doing for 10 to the power 3. So it should be G value is now minus 90.83. So magnitude we have to write, better to write directly 19.83. R2 by R1 is simply 100. R2 by R1 100. Okay, R2 by R1 100 by 100. So it should be minus what? We can directly write minus 9.17. Okay, or into 100, because if we this 100 cancel, so this should be minus 9.17 percentage. Okay, so this one is simply minus 9.1, means G minus R2 by R1, R2 by R1 into 100 percentage. So R2 by R1 is 100. So this one and this one will be cancelled. G minus R2 by R1. 90 minus 83 minus 100 minus 9 point. So this value will be minus 0.17 percentage. Okay, so I am not writing, or you can write percentage. Now we have to find the V1, the value of V1 at this point. Okay, so value of V1 will be minus V naught by A. Okay, so now what we have to write? V naught is nothing but simply minus G times of Vi by A, because this one is the overall gain, this one is V, and we are saying this one is Vi. So G equals to V naught by Vi. So V naught equals to minus G times of Vi by A. So now directly we can write G, we have calculated how much, minus 90. Okay, 19.83. Okay, so we have to write it 19.83 into Vi. Vi is given 0.1 volt. Okay, Vi is given 0.1 volt. So make it 0.1 volt and make it 10 to the power 3. I have already did the whole calculation. So it should be minus 9.083. Okay, into 10 to the power minus 3 means minus 9.08 millivolt. So these are the answer. Means, okay. So this value will be simply our minus 9.08 millivolt. Okay. First part for G equals to 10 to the power 3. Now similarly we have to do it for, okay, now we will do little bit fast. For A equals to 10 to the power 4, means when the loop gain is, open loop gain is 10 to the power 4. So what we will do, gain at A equals to 10 to the power 4. Okay, so R2 by R1, R2 by R1 will be always 100. Okay, then 1 plus 101 by 10 to the power 4. Okay, so it is minus 100 by 1 plus 0.0101. So if we solve this one, it will come nearly minus 99. I have already solved, very simple. So this value will be our now minus 99. So we are writing magnitude, so better to write in 99. Okay, now G is now known to us. Now the relative error. So G minus R2 by R1. So it should be minus 99. So make it plus 99, because magnitude minus R2 by R1 100, R2 by R1 100 into 100. So this should be cancel out. It should be minus 1%. Okay, so percentage eta is also now known to us. Now the V1 value will be minus G times of Vi by A. So G is our 99. So make it 99. Vi 0.1 by 10 to the power 4. Okay, so if we solve, it will come nearly 0.99 millivolt. Okay, so I am writing here for 10 to the power 4, it should be 99, and this value will be minus 1% simply, and it should be minus 0.99 millivolt. Now we have to do it for 10 to the power 5. Okay, these are the, you can say, the answer. Okay, now for A equals to, for A equals to 10 to the power 5, we have to find. Okay, so what we will write, overall gain at 10 to the power 5 means R2 by R1 100 by 1 plus 101 by 10 to the power 5. So if we solve this 100 by 1 plus, if we solve like 0.00101, and if we solve overall, if we solve, it will come minus 99.90. Okay, so magnitude will be 99.90. Then we have to find out for the percentage efficiency relative error. So g2 by g1 means, sorry, minus g minus r2 by r1, okay, by 100, r2 by r1 100 into 100, this 100 cancel out, and 99 point, so 0.100 with minus sign. So this will be the percent, minus 10%. Now one more thing, v1 we have to find. Already it is very simple one. I will share the video, okay, means how to write all these things, okay, the full theory video we can say. 0.1 divided by 10 to the power 5, if we solve this one, it will directly come around minus 0.10 millivolt. So these are the thing for 10 to the power 5. Okay, so for 10 to the power 5 we can directly write here. For 10 to the power 5 it is coming 99.90, and it is coming minus 0.10%. Okay, means percentage uh, error, and this value v1 value will be 0.10 millivolt. This one is about part A. In part A they have asked what is the percentage error in magnitude of g related to the ideal value. So percentage error g minus r2 by r1 by r2 by r1 into 100 v1, and v1 also they are asking that we have find v minus v naught by a for vi 0.1. So we have already calculated. Now the second portion, if the open loop gain A changes from 10 to the power 5 to 15 to 10 to the power 3. So for second case, for part B, okay. In part B, they are asking A value, it changes from 10 to the power 3, means, sorry, how much? Once again, I have to check what is in the question. 10 to the power 5, okay. Means A value is changes from 10 to the power 5 to 50 into 10 to the power 3. Okay, so what should be the percentage change? Percentage change we have to find. Okay, for A is equal to 10 to the power 5, we have already find the gain expression. Okay, it is coming minus 99.90. Okay, now similarly for A equals to 50 into 10 to the power 3, we have to find the gain expression. So the gain expression will be, the overall gain will be minus r2 by r1. Once again I am writing the thing, 1 plus 1 plus r2 by r1 whole divided by a. So it should be minus 100 by 1 plus 101 by 50 into 10 power 3. And if we solve, it will come nearly minus 99.80. Okay, means when the gain is, open loop gain A changes from 10 to the power 5 to 15 to 10 to the power 3. When A is 10 to the power 5, I am highlighting this one. Means when A is 10 to the power 5, the gain is minus 19.90. When A is 10, A is 15 to 10 to the power 3, this value is 19 minus 19.80. Okay, so we have to take it modulus. Okay, so what we have to do, we have to find the percentage change, this percentage change. Okay, so this percentage change will be mod gain at 10 to the power 5 minus gain at 50 when the drop in the open loop gain by 50%. So again we have to write g, we have to find percentage change, okay, into 100 we have to write. So it should be around 19.90 minus 19.80 magnitude, okay, then 99.80. Okay, so it will come around 0.10 by 99.80 into 100. So if we solve, it will come 0.10 percentage. What it means, if we solve, it will come like this. It means if minus 50% change in A, open loop gain, 50% change in A, the closed loop gain changes in only minus 0.1%. Then minus 0.1% change in closed loop gain. Okay, means the gain, closed loop gain value, even there is a 50% change in the open loop gain, the overall change in the closed loop gain is very less. So this is the problem, and this problem is from the microelectronics circuit book, and this one is the exercise problem. You can also go through the book. So means here this one 8 into a 5 to change from A to 15 to just 50% drop. When even if the 50% change in A causes only 0.5% change in G. G changes in only 0.1%. Okay, so this one is the very good problem from the microcircuit book. For theory, you can go for my uh, other video, means video related to this one. I will share the link. Okay, this is all about this video. So thank you for watching this video. Thank you.